Thank you for being patient, Dick. Thank you.
Well, it's been an absolute pleasure to be patient. I have to say that was an extraordinarily comprehensive, detailed and accurate assessment of all of the issues surrounding where we are today. But the relevant phrase, of course, is we are where we are. And it's good to be able to look back and take lessons from other sectors and go back to 20 plus years to where perhaps the airframe OEMs began to lose their way, and think about lessons learned and what they could and should be doing differently. That doesn't help the airline customers today that are facing into these huge, unexpected and frankly unacceptable level of financial penalties over which they have little or no control. And I think you're right to put the spotlight on Indian Airlines because they are taking an excess share of the brunt of the pain just by dint of the size of their order books, the scale of their new technology narrow bodies in operation, and the level of utilization they need to get out of their fleets. But I think if we go back to, if you like, the sort of root causes, I would say there's really three areas which take us to where we are today. One, as you rightly say, is the shift in the OEM cultures, the vision of leadership, the demands put on an industry by shareholders and shareholder returns, and how that has led to a parting of the ways between, and I would use Boeing as an example, what for the first 95 years of its history was an engineering-led company, and for the last 20 plus years has been a finance-driven company. And I think that helps to explain a lot about where things have gone wrong from that side of the house. But there's two other areas which I think are equally important. The one you just alluded to is that aviation, more than almost every other industrial sector, has relied upon the evolution and rarer step change revolution in technology to drive efficiencies, to drive down costs, and to make aviation the global leader it is today in terms of communication and moving very large numbers of people efficiently over increasingly long distances. And to do that, which is essentially what the airline customers are telling the manufacturers they don't want speed. The Sonic Cruiser was the last example where the market was tested for speed, and no, it's too expensive. We want a more efficient aeroplane in terms of driving down unit costs. We need to be competitive in the market. And the Indian Airlines that have adopted NEO with such enthusiasm have all done so on the basis that it gets them a 20% cost advantage in the most expensive operating cost item, which is fuel. And that gives them leverage in a market where every cent in cost savings can and is, not necessarily should be, passed on to the customer in lower fares. So the customers are, particularly on narrow body aircraft, saying we want to drive our operating cost, our unit cost down to as low a level as possible. And that means new technology. And as you've rightly pointed out, historically, induction of new technology creates problems because it's never as easy and straightforward as the manufacturers would like the customers to believe it is. And we've seen that going back to the RB211 and even before that. And it brought industries to its knees. But we come through it. As an industry, we can survive that. And the airlines more than ever today understand what risk they're taking on when they go into a new program with significantly improved, materially changed structurally power plant. Because let's face it, most of the evolution to date has been in power plant. It's not in the airframe. So when Indigo goes out and places initially 100 orders for A320neos and then follows it up with another couple of hundred, another couple of hundred, it knows full well what potentially could go wrong. Perhaps not the scale of what could go wrong, but that it's not going to be risk-free and it's not going to be problem-free. So that has to be factored into every airline's fleet planning decisions today. And over time, we'll work our way through that. And the fact that some of the technological problems are not to do with the evolution of technology, but to do with issue number one, which is the OEM's cultural shift and its loss of control over the supply chain, to put it bluntly. It all rolls up into the same net problem. The third issue is the loss of capacity, skills, funding across the industry, and particularly down the lower levels of supply chain, caused by, firstly, the global financial crisis, and secondly, COVID. So the global financial crisis took huge amounts of finance out of the world economy, and that slowed down the ability of second and third tier suppliers to keep up with the demands of their customer OEMs. And COVID took people out of the equation, and there were huge numbers of furloughs, layoffs, losses of skills, which you can't immediately recruit back in and fire up to 100% efficiency. And if you take that into account, it's not something that's come immediately out of COVID. It goes back longer than that. But there has been a deterioration in the qualities needed further down the supply chain to meet the increasingly large volumes of supply and the increasingly higher levels of technology in terms of metallurgy, or it's not even metallurgy nowadays, but it's carbon fiber and composites, and the crystals, single crystal turbine blades that are being grown to put in very high temperature environments in large engines, etc., etc. The skill sets aren't there. They're not ramped up to where they were. Yet the scale of the requirement doubles every 20 years. The number of aircraft in service doubles every 20 years. So the last time we hit this crisis and the time before, we were looking at a market which was a quarter, three quarters, significantly smaller than it is today. So the problems today are magnified, and that's reflected in the scale of the US dollar impact, which your analysis, I think, is pretty accurately reflecting. The challenge for the airlines, and particularly in India, where we are at another inflection point, for the first time since the early 1990s, we have the ability to create a stable, well-capitalized, well-managed industry players that can operate largely without government interference. There's not actually that many people amongst the hundreds of millions of travelers on Indigo, SpiceJet, Go First, etc., who are in their 20s and 30s, who will remember the very first iteration of low-cost air travel in India, and how that was run into the ground. And we need to be very careful for all the stakeholders, and from government right the way down to the financial sector, to make sure that it doesn't hit the rocks again, because we are going to see airlines in crisis, in restructuring, in failure, and that in itself is not necessarily a terrible thing, because it does drive change behavior. It does allow consolidation. It does allow the competitors that remain standing to become more efficient and become tighter and more consolidated and begin to regain control, not just of the cost base, but also of the revenue base. What we're seeing now in terms of disruption of having 20–25% of the fleet grounded for reasons outside their control, and a pretty difficult challenge in finding replacement capacity, because there's very little left in the global market. It's all been taken up already. There's not much additional A320ceo and 737NG capacity that's not already been taken up and operated. The lessor availability is close to zero. So where they are today is probably about as good as it gets. And as the number of aircraft going on the ground for inspections increases over the next couple of years, and I think it will be a 2 to 3 year problem, we are going to see capacity inevitably come out of the market. Hey, that should lead to higher fares. If it's an efficient system, if it works on basic economic modeling, capacity control is not a bad thing. Look at the US domestic airline industry. They've been squeezing capacity out for 15 years, and who makes all the profits now in the global airline industry? 65–70% of it comes from the US airlines, and very little, frankly, from the Asia region generally, because by and large, everybody in Asia Pacific has been taking on big fleets of airplanes, and they've been ordering aircraft on behalf of themselves and a bunch of other people as well. And overcapacity drives down fares and drives down profitability, unfortunately. So look, yeah, go on. That in a nutshell is my initial take.
Before I come to more specific questions, I want to start by looking at the state of the alternate capacity. Now, in the winters, it's possible that most of the European fleets, a significant part of the European fleets are grounded, and then you have at least opportunities for about 5-6 months, possibly more. How do you see the alternate capacity shaping in the summer of 24? And how, I mean, by our research, with our consultations, we believe that supply is going to be even tighter this summer. Hardly any planes, hardly any spare engines available. Just throw us some light on what would you think the summer 24 to look like in terms of alternate capacity?
Well, I think globally it's going to be below where the airline industry had planned it to be and would like it to be. There's no doubt we're still going to be seeing, a significant amount of rebound growth post-COVID. Most of that will come in Asia Pacific, and a lot of that will depend upon the remaining Chinese travel market opening up, which I and others think it will. Most of the rebound growth in North America and Europe has probably already happened. But I think there's still scope to increase on the summer 2023 capacity in terms of demand. In terms of supply, I think you're right. I don't think we're going to see anything like the level. We're absolutely not going to see Airbus or Boeing meaningfully increase their production rates on narrow-body aircraft, which is really where the demand still is coming from. I think they'll manage to get up their production rates and their delivery rates on wide bodies, because there's more recovery needed in that segment of the market. But in Europe, most of the volume travel comes from the short haul. If you look at Ryanair, Wizz Air, EasyJet, and to a lesser extent, the Lufthansa's, British Airways, Air France's of this world, most of their growth expectations would be in narrow body and short haul. But they're also facing the same problems of aircraft being grounded. They're not getting the level of deliveries out of Airbus or Boeing that were contracted. And they've also had problems in some cases in getting aircraft that they put on the ground during COVID for all the right reasons, getting them back in the air. And there's one piece of the supply chain we haven't talked about, and that's the supply chain for the aftermarket in MRO and engine shop capacity. There is none, because of all the aircraft coming back out of COVID storage, where the airlines had deferred maintenance and engine maintenance events to conserve cash, despite a lot of very attractive offers, particularly from the engine manufacturers, saying, please, please, give us your engines for that scheduled shop visit now in 2021. We'll defer terms and make it financially a no-brainer. You should just put your engines in the shop, because if you don't, there will be a capacity constraint when everybody's flying again. No airline took up that offer. And now you have a long wait for MRO capacity if you need to do any airframe work, which on 12-month checks is pretty likely if you've had an aircraft in storage for any length of time, and more important, for engine shop visits, which are now going to be overloaded by all the additional inspections. And I understand that the lead transit time now for inducting an engine into a shop visit is around about 300 days from the point at which you go to the shop and say, I've got an engine, when can you take it, when can I get it back? Their answer is, well, from the waiting time, transition time through the shop to getting it back on wing, 250 to 300 days. So there you've got another 3/4 of a year in lost time on every engine and every airframe, because of no spare engines, because CFM and Pratt & Whitney are not building spare engines because they're running flat out to keep the production lines filled. So there's all sorts of issues why capacity next summer is going to be quite heavily constrained.
I wanted to ask you, we talked about the replacement capacity for aircraft. Just walk us through the kind of capacity crisis we are seeing for shop visit capacity, whether it's OEMs or third-party players, because you had about 600 engines which was not planned for, and you have another 500 earlier, and then if you see by a very indicative structure, an airline like India would require 250 to 300 replacement engines. If there is no shop capacity, because these were not planned for, and we are talking about a combined about 1,000 extra engines, which would need shop capacity for about 300 days. How bad is the maintenance capacity either at the OEM facility or a third party to be able to cater to something which was unscheduled?
Well, I think it will get worse before it gets better. I think, you know, at the beginning of the year, we were probably looking at 180 to 200 days to get engines through a shop visit. That's increased to 250 to 300. It's not going to come any lower because, you know, the engine shops are now blocking out the next 12, 18, 24 months for the unplanned maintenance, which is coming down the line, which is, you know, primarily in the Pratt shops, and also for the planned maintenance, because, you know, the engines that are on wing or the new technology are staying on wing for less than half the time that the CFM56 was on wing. And I remember when, you know, the engine manufacturers were selling their benefits of the new generation LEAP and GTF, saying it's going to have at least the same on-wing time and it's going to have no higher maintenance costs than the current generation engines. And they were blowing smoke. They didn't know. And they were using their balance sheets to guarantee it. So, I mean, we're just diverting a little bit in terms of, you know, how much compensation can the airlines expect to get from all of this? I think
second question, but before that, I just wanted to check. We talked about the compensation. Before I come to the compensation, we know that the replacement capacity is almost dried up. The engine capacity for about 1,000 plus engines, which were unscheduled, isn't there.
And we've known for a long time. We've known for a long time that there's insufficient.
I think you're on mute. Sorry. No, you're fine. You're fine.
Okay.
At our end. Before I come to the compensation structure, walk us through what next can we expect? We know that the powder metal issue. We know that for example, a market like India, the engine thresholds have moved from, let's say, 9,000 to 4,000, and that will create its own challenge. What next can we see from about the new deliveries? Now, there are new deliveries that are planned, which possibly, as of now, are expected not to have the challenges of let's say that the 1100G is facing. Do we expect all the new engines to have the replacement discs in place, because there are massive deliveries that are planned, not just India and globally? Walk us through what will happen for the new deliveries. Is the OEM going to be in a position to ensure that all the new aircrafts have the discs in place, which have been inspected and examined and put across there? Because we know that planned capacity is a risk. The alternate capacity is a risk. Spare engines are a challenge. There are 1,000 aircraft engines which are unscheduled. Now there is this banking that we will get new engines, new aircrafts into picture, but will they have the discs that will be replaced so that we don't face the same problem? Or they may partly have some which will be replaced so that they don't have the same problem as powder metal issues? Or 50% could be with new disc, and 50% could continue to have a powder metal issues, and you run your airworthiness directives as you have done before. So walk us through the new deliveries and its impact.
Sure. Well, look, I don't come from any position of knowledge and certainty on this, but my suspicion is that there will be a proportion of engines delivering, we're really talking about GTF, so delivering to Airbus on the production line. A proportion of those will be exposed to the risk that there will be materials involved in the build-up that will require earlier inspection and replacement. Because on the one hand, you know, Pratt & Whitney is going to be saying, well, we need to fix this problem, so let's just in an ideal world, let's just stop production until we fix the manufacturing, and then we guarantee every engine will be delivered in perfect condition. But they've got customer pressure, not from the airlines, but from Airbus saying, hey, come on, we've got a production line. We can't shut our production line. We're building 45, 48 airplanes a month. We're not going to stop 3 production lines around the world. You're going to have to keep delivering engines at the contracted rate, and we're going to hold you to that. And you need to figure out how to fix your problems. Your supplier, you're on the hook here. So I suspect that they will have to continue to deliver a proportion of engines that will have manufacturing quality control defects.
Then it takes me to the next question. Assuming that some of the deliveries will have the same issues, the discs are not properly checked and extra. Walk us through what next could we expect. Let's assume that the industry in their risk assessment factors that we will have some lower thresholds. So in the LEAP, in the GTF, we have now this new powdered metal issue. The discs will be changed. Some of the new aircraft deliveries will get impacted. But is that the end, based on your experience? Is there another what-if scenario? And that's my biggest challenge, whether it is across the OEMs. Is there any challenge that we find, okay, after the disc issue, is there anything new that we will find? And an impact on an industry in India is going to be catastrophic. So tell us through your experience, that have you seen the end of the risks or there is more to come?
Well, every time we find another issue, we say, well, that must be the last. And of course, it isn't until at one point it is. But who can tell when that's going to be? But the impact on the availability of capacity is going to continue. That bow wave on the chart is not going to gradually come down. It's going to continue to be sustained. And we are going to see more inspections or additional inspections required, out into the future. And then we've got the higher frequency of scheduled shop visits, just because of the inherent challenges of the more complex construction of the engines, particularly in the hot sections, more exotic materials, more materials subject to wear. I think that with a little bit of irony, of course, with the GTF, pretty much the only piece that hasn't shown any issues at all is a gearbox, which is what everybody said was going to fail and be a disaster. So let's thank heaven for small mercies, but that doesn't even get inspected on every shop visit. The reality is we've known for a long time that we do not have enough engineering capacity in the industry to take the industry forward at the same level of growth as they've been enjoying historically. Boeing and Airbus both talk about the need for about 600,000 new mechanics over the next 20 years. And those mechanics have got to have some facility to work out of. We need more MROs. We need more capacity. And the really good news for India is that we're now going to get one. India probably needs 2 or 3, but, building blocks. We said for a long time, we need homegrown talent. We need homegrown capacity. We can't be shipping every engine out of the country and then re-importing it again. So I think there's some good news there on the horizon. The bad news, of course, it's not going to open in the next 12 months, but everyone around the world, particularly in emerging markets where all this new capacity is being delivered, needs to be more self-reliant locally on the basic requirements of airplane and engine maintenance. And that will come slowly, but I think this will be a catalyst to make it happen a little bit faster.
Then let's come to the compensation structure there. Now, a thumb rule for us is about 6 million a year. And that's basically your airframe maintenance cost. We've not taken the engine cost, the lease rentals, and we're assuming that the staff and other costs, crew cost and other costs get utilized for the replacement capacity. So we've taken a very broader, very conservative number at about 500,000. Then obviously the lease extensions will cost you more. The complexities are going to be addressed. Spare engines need to be addressed. If you take that out and look at 5 million to 6 million a year, how does the industry get compensated in this crisis? Now, when you have I think the in compensation structure earlier was different, and obviously it depends upon your contracts. Indigo's contracts, every comma, everything is structured and tight. My understanding of other airlines would be that it's not as tight as possible. But within the contracts that we have, those have been also changing as the magnitude of the problem has emerged. Now, take us to a compensation structure, 6 million a year, let's say our assessment is indicative. What could the airlines expect based on your experience after that there has been a 7-year challenge and you're moved from the revenue compensation to, let's say, $200,000 a year? What can we expect in terms of mitigation from this on the 6 million side?
Well, I think the compensation for the technical shortfalls are relatively straightforward. The majority of these engines will be in power by the hour structures because Pratt & Whitney was pushing this extremely hard. When engines come off wing, go into an engine shop, that's all part of the pay-as-you-go structure. If an airline has been on a pay-at-shop visit structure, it might be slightly different, but I think in any event, there should be very little to debate about, putting the engine, into a Pratt & Whitney facility, getting the full restoration, and that will be covered under the power by the hour agreement. And I think it's instructive to note that both Pratt & Whitney and CFM have basically withdrawn those power by the hour agreements from the market at the present time. They're obviously done the maths, realized what that's going to mean to their balance sheets. Outside of the technical compensation, you've got two elements. You've got one, I've got the aircraft on the ground, it's doing nothing, and I've got fixed costs. So how are you going to compensate me for money out the door for lease rates, for example, where aircraft I can't utilize? How are you going to compensate me, if I do utilize the aircraft for the spare engines I'm having to lease in, and all the time I'm not flying the aeroplane, or I've got an on-time performance issue and I'm losing market share, et cetera, how are you going to compensate me for lost revenue? And that has always been the most difficult to pin down. And I would say the least successful in terms of airlines getting a satisfactory outcome. That it is, even with the most tightly worded contract, it's been really, really difficult for airlines to get a quid pro quo compensation, because lost revenue is has to be a bit of an estimate. It's how are you going to pay me for the money I can't show you? Well, how do you quantify that? Is there a cap on it? Is it based upon an hourly rate? And again, it will be case by case. So you're right. I mean, some airlines will have a very clearly worded contractual obligation, and some airlines will have absolutely nothing at all. But for sure, that's where the OEMs are going to dig their heels in, and they're not going to write a blank check based upon what the airline asks for. That will be a case for the lawyers to debate over the next 3 to 5 years, I would say.
Two things, just to a follow-up question to that. One is that I have an engine under the scheduled maintenance, power by the hour, and I need to take it to the shop, and obviously I would need to do a full restoration. So that part I understand. That's why in our numbers we have taken, let's say, $500, $600 per aircraft, $250, $300 per engine. We've taken that off. In addition to that, I have a lease rentals that I'm going to pay if the aircraft is going to be grounded for a year. I have an airframe maintenance cost to be paid, and if I don't pay anything else, I have a lease extensions which will cost me money. Let's assume that it's 6 million a year. What is the best thumb rule for you in terms of what compensation, apart from restoring the engine under the power by the hour PBH arrangements with?
Well, if I was the financial planning manager in that airline, in terms of thinking about what level of liquidity I need to raise, I would say, let's assume compensation is 0 and work back from that number. So if you're going to go and you're going to raise more money in the markets, to cover your liquidity position, assume you're going to have no compensation over the next 1 to 2 year horizon. And then anything you get beyond that doesn't mean to say you sit back and say, well, we've resigned ourselves to not getting any money. You still aggressively pursue it. But I don't think it would be prudent to assume a starting figure of more than 0. And then anything else you layer back in as it comes in.
India specifically, Dick, and our assumption is that we are a very fragile airline industry. We've always had losses, and these losses are magnified during COVID. Currently, we may lose 1.6 to 8 and possibly go more. Such an impact, which could last for a couple of years. How does an industry address such risks? That's with the knowns that we have currently, that listen, we now have a powder metal issue. We know the LEAP is going to go 6,000 from 9,000 to about 4,000 in terms of cycles. We need replacement engines. We're not sure what's going to happen next. Minus that, how does an industry like India, which is going to be the largest market for decades, how does it address, because it's going to be very vulnerable, it's going to be hit hardest. How does it address it? If you were to advise the airlines as well as the government, what would you say?
I would say adopt the same principles that you adopted when COVID took control of your destiny. What did you do then to survive? You went to everyone you could, cap in hand, and said, we need to raise more liquidity. We need to have, a liquidity cushion to get us through the next 1 or 2 years. And we will do that by going to our lenders. We will go to our shareholders. We probably won't go back to our lessors, because I think that they probably contributed a significant amount already. And they're going to be facing their own issues because of the lack of deliveries and availability of aircraft. And I certainly go and have another bash at government about, helping to take some of the tax burden off. If ever there was a time of normalizing ATF taxes into the GST system, this is it. You could go for low-hanging fruit, high-hanging fruit, whatever it takes. But again, assume that you're going to need everything you can lay your hands on. And those with the deepest balance sheets and the largest levels of cash liquidity are going to survive the longest.
Last question before we come to the audience question. Give us a best case scenario and a worst case scenario.
Best case scenario is that the powder metal issue is isolated, a fix is implemented in the manufacturing side, and that works its way into all new engine builds from January 2024. That Boeing is able to get control of its 737 manufacturing, rework issues, and start delivering those delayed 737s at a higher rate than is currently expected to be. And that the discussion on compensation goes down a happy route rather than an unhappy one.
Okay, so we will go now through a couple of questions, and thank you for your patience. We have an anonymous attendee. In the case of LEAP, it bears from the presentation that reliability issues have increased inspection, which may lead to reduced utilization due to scheduled events. Grounding of LEAP aircraft, if they have occurred, would mean non-availability of line replaceable parts, small components, and possibly consumable and tools, typically following an unscheduled maintenance event, or the non-availability of spare LEAPs for QEC, which is the possible shortage of parts for a LEAP, a factor in possible grounding of LEAP-powered aircraft. Would be interested to understand. Any take on that?
Well, I think the focus on the industry, of course, has been, maybe unfairly all on Pratt & Whitney. The LEAP has not been without its problems. And, the fact that there are, demands on CFM to, produce ever more engines, and the fact that they were a little bit blindsided in the need for spare engines so early on, means that there will continue to be a shortage. And LEAP, like CFM, like Pratt & Whitney, is going to be driven by contractual requirements to deliver engines to final assembly lines. rather than into the spares market. So I think there will be a shortage of spare LEAP engines over the next 2 to 3 years, which is bound to impact the ability of airlines to maintain a level of operation as they find more engines coming off wing faster than expected. On top of the overbooking situation in the engine shops, which is going to slow down the throughput as well.
Second question is, can we expect any repeats and possibly industry initiatives addressing events like AOG techniques? I mean, aircraft on ground. Is there anything that you think there are industry initiatives that can address the issue?
Well, I think the regulators need to enforce. I mean, it's good to see that the AOG, principles are now being examined by the Serious Fraud Office and, probably face jail terms. I don't think you can overstate the seriousness of this. I mean, they are providing bogus parts now, not even PMA parts, but definitely not PMA parts. They are providing fake tags on serviceable, non-serviceable items, any of which can find their way into a critical area of an engine and bring down an airplane. This is a procedure that will kill people if it's allowed to spread. And the difficulty is at the moment, it's been nipped in the bud fairly early, but there's an awful lot of components out there which we're not aware about. Ryanair discovered them in 2 of their airplanes or 2 of their engines, I think, only a couple of weeks ago. So we're beginning to see these things emerging. Fingers crossed, AOG is the only organization, the only crime syndicate involved in this, but who's to say that there's not other bogus parts floating around the system? And we as an industry need to come up with a fail-safe way of catching them. Now, it's good that a lot of these early parts were caught by inconsistencies picked up by individual technicians when they were moving parts through the system, but it shouldn't even get that they go into the system. So I think we've got a real challenge systemically to make sure that we nip this in the bud, because it is massively dangerous.
Thank you. Last question, and you may like to give a quick answer. Airframe OEMs and integrators have prioritized supply of engines for supporting ambitious plans to ramp up production to delivery on their large order books, rather than retaining rates to allow engine OEMs and supply chain restock the global pool of spares to support airlines meet operational requirement. Is there a way out of this cycle? Question, Dick.
Yeah, look, I think inevitably the industry today is driven by volumes and shareholder returns. And it's interesting, looking at your lessons learned from Toyota, the fact that they hit the pause button and went back to basics. I do have to say, I think the Japanese are better at humility than the Americans and arguably the Europeans. I think to press the reset button in Boeing or even in Airbus and saying, hey, we have to go back and revisit our whole approach to production rates and shareholder returns, and we need to get a more balanced industry. I'd love to believe that was going to happen. I just don't see it.
Thank you, Dick. It's been an excellent conversation, and we'll have a video of that on our LinkedIn and other social media channels. It's always wonderful talking to you. Thank you for joining us. I think that not only my team, but everybody in the audience was greatly, I'm thankful for you for being generous in terms of your time, as well as sharing your knowledge. Thank you very much, and I'd like to hopefully see you soon. Thank you very much. Thank you, Dick.